Now we will discuss about simple microscope and later then we will discuss about compound microscope. Simple microscope is nothing but a magnifying glass. Palmstrium uses this magnifier to read the lines that are present on the palm, and similarly to see microfilms or very small objects we use a magnifying glass. Now we know that the image appears to be clear only up to minimum distance, and you can even observe that when the object is nearer the eye, it appears bigger. When it is farther, it appears lesser. The reason is the angle made by the object or the image of the object at the eye is responsible for actual magnification. So, by increasing the visual angle, a lens makes the image appear bigger than the actual size of the object. So, this we actually call it as angular magnification. So, that is called as actually angular magnification. Suppose we define it like this: the tan of angle made by the image at the eye by tan of the angle made by the object at the eye. So here I have shown you that convex lens, and in front of which the object is kept. To see the magnified image of the object should be at a distance less than its focal length. So like that I have shown here. Now for one position, let us say the image is formed somewhere here. Now let us take this AB. Suppose it is here at the distance of the image, say somewhere here. The angle made by the object when it is at the image distance, let this be say some alpha, and the actual image is making an angle beta. So, or we can say this angle made by the image at the eye is beta, therefore tan beta by tan of the angle made by the object when it is at the image position is say some alpha. From the figure you can see that this is equal to tan beta is A dash B dash by, so let us call this as O, optical center of the lens, so O B dash. Similarly, tan alpha is again equal to the size of, because this is equal to the size of the object, linear size. So say h by the same distance OB dash. So OB dash gets cancelled. So let us take this A dash B dash as equal to say h dash, and the AB, the linear size of the object as h. So what we get is, this is h dash by h, which is nothing but linear magnification. Angular magnification is equal to linear magnification. That's what we got. Now, from the figure, if you observe the triangles, so triangles from A dash B dash O and this one ABO, they are similar, therefore the ratio of their opposite sides must be equal. Therefore, A dash B dash by AB must be equal to OB dash by OB. Therefore, H dash by H is equal to OB dash by OB, which is nothing but image distance by object distance. Image distance by object distance. So that is equal to V by U. So what we have shown here is the angular magnification is equal to linear magnification, and hence M is equal to V by U. So let us suppose, since M is equal to V by U, if the image is formed at least distance of distinct vision, the magnification will be maximum. and I can see the image clearly. So in such case, V can be taken as D. So that is equal to D by U. But from the lens formula, that is 1 by V minus 1 by U is equal to 1 by F. So here the distances V and U are all negative, and the focal length of the convex lens is positive because the focus you can take it to that side. Now, so take this minus 1 by V to that side. So what will happen? Therefore, 1 by U is equal to 1 by F plus 1 by V. So, therefore, magnification M is equal to that is V D by D into, in the place of 1 by U, I am writing this one, 1 by F plus 1 by V. So, that is equal to D by F plus D by V. But as I said earlier, the image distance itself is equal to D. Therefore, substitute for D, that D gets cancelled. What we get is D by F plus 1. So, that is the formula for magnification when the image is formed at least distance of distinct vision. So, generally, we write like this, M is equal to 1 plus D by F. So, where D is the least distance of distinct vision. Suppose, if the image is formed at infinity, so what happens? Let us derive that formula. We know when for clear vision, the minimum distance we have to keep the object from the eye is D. Therefore, the tangent of the angle object makes when the object is at least distance of distinct vision. Say you have kept it at a distance of D. Therefore, let us suppose h is the size of the object, and the minimum distance you have kept it at D from the lens. So h by D is the tangent of the angle made by the object at the eye. And when the image is formed, so I have to change the figures. I will explain it here. So the image is somewhere at infinity. Therefore, whatever angle it makes here is the same angle. So, because the image is at infinity, you cannot show the rays. You can take as after refraction parallel. Now, say this is a theta image. So, theta image. And from the figure, so we have kept it here. This is the object. And for final image to form at infinity, the object should be kept at a distance of its focal length. So, the distance of the object from the lens must be equal to the focal length, because if you keep the object at the focus of the lens, then the image is formed at infinity. So, by image construction method or by doing experimentally, we can see that the image is at infinity when the object is at the focus of the lens. Therefore, in this case, tangent of theta I can be written as, that is, let us suppose you can take the image somewhere here. Therefore, height of the vertical length of the image by the that is equal to this. Therefore, you can put the h by f, because you cannot measure the image because that's a virtual image. Therefore, so this is the length of the object, this is the distance of the object. Hence, this is theta is equal to h by f. Therefore, the angular magnification, which is equal to linear magnification h by f by h by d. So that h gets cancelled. So d by f. So this is the formula for magnification when the image is formed at infinity. So this is for relaxed vision. So for relaxed eye, the image should form at infinity. There is only small difference in the magnification. That is 1 plus d by f when the image is at the least distance of distinct vision. When it is at infinity, it is only d by f. Okay. So in that way, we can derive the formula for magnification by a simple microscope. And a simple microscope has limited magnification. Only can magnify nearly by 9 times. So in order to achieve more magnification, we use 2 lenses or more lenses in combination. And hence such a system in which 2 or more lenses are used to magnify the size of the image of the object is known as a compound microscope. The construction of compound microscope is like this. It consists of 2 lenses. One lens kept near the object, so in front of which the object is kept as objective. This is objective. And the lens through which we see the final image is called eyepiece. Eyepiece. Now, these 2 lenses are coaxially arranged in a tube, and the distance between the lenses are fixed. The distance is fixed between the lenses, and there is some arrangement such that the distance of the object from the lens can be altered by using with the help of a screw called as drop and pinion screw. So it is inserted in a tube such that the distance of the object from the lens can be adjusted, but the distance between the objective and eyepiece is fixed. Okay, so they are arranged coaxially in a tube, and you see the object will have shorter focal length, eyepiece has larger focal length. Then how the image formation takes place, that is shown in this diagram. The object is kept very nearer to the focus of the objective, just behind the focus. So you get a real inverted image formed behind this objective. This acts as object for the eyepiece. Now the distance between the object and the objective is adjusted such that this A dash B dash is formed very nearer to the eyepiece at a distance less than its focal length, because this is the focus of the eyepiece. So you will get a image which is nothing but a virtual image. A virtual magnified image is formed because for this object, this image acts as object for this. It works like a simple microscope. Suppose if the image is formed at least distance of distinct vision, then what is the formula for magnification? It is nothing but, in a combination of lenses, the image formed by one lens is further used as object by this other lens, and again image is formed. Therefore, the magnification of the combined system is the object magnification due to the objective lens and magnification due to the eyepiece. Now, magnification due to the objective, it is just nothing but image distance by object distance. You can write like this V by U. And since it is forming the image at least distance of distinct vision, you can write 1 plus D by F eyepiece. Here, if you observe, we are keeping the object very nearer to the focus. So therefore, you can take U nearly as equal to the focal length of the objective, very near. And the image A dash B dash is very nearer to the lens eyepiece. So distance is called as the length of the microscope. Therefore, that V is really equal to the distance between the lenses. Can take it as L. In such case, the resultant magnification is written as L by F4 into 1 plus D by FE. So this is the formula for magnification of compound microscope when the image is fine image is formed at least distance of distinct vision. Similarly, suppose for relaxed vision, the fine image is formed at infinity. So when the fine image is formed at infinity means you have to adjust the distance between the object and distance, and this image should form exactly at the focus of the eyepiece. Then the fine image will be at infinity. In such case, you know the L by F4 and the formula for magnification of the eyepiece changes as in the case of microscope into D by F. So this will be the formula. Okay. So in that way we can understand the working of a compound microscope. But truly speaking, microscopes used in laboratories, instead of one single objective lens or one single eyepiece, they use combination of lenses to get more magnification, more clarity in the image, and to reduce the defects that arise due to chromatic aberrations and spherical aberrations. So for minimizing such defects and to have more magnification and clear vision, oil immersion eyepieces are used, and similarly the objectives are also combination of lenses, and the magnification also depends upon the wavelength of light used. By using shorter wavelength of light, more magnification can be achieved. So that's about the compound microscope.